What's up guys, Shawnthebro here, and today we're going to be covering throws and grapples in the fighting game tutorial series. Now this is part 1, there are going to be at least 2 parts on this, and mainly after today you'll be able to actually grapple your opponent, obviously, and throw them to the other side of you. So we're actually going to be doing a back throw today, actually just because it's the animation that I grabbed. Not for any reason in particular. The only real difference between a front throw and a back throw as far as this episode is concerned is just where the enemy ends up. But there's going to be a few things that we're going to need to fix in another episode. So let me show you how it works. We can use an attack to perform an attempted throw. It spawns a blue hitbox, which is a new hitbox type. As of now, we're only using one button to perform it. I was never using my heavy attack to actually perform an animation. So I've used my heavy attack to perform the throw. However, we will be covering using more than one button, so pressing 2 buttons at the same time to perform actions in the series. And a lot of times that's how throws and grapples are done in fighting games. So we will most likely transfer over the logic to use that input to perform the throw. But for now, I'm just using my heavy attack. So if my throw hitbox does not collide with an opponent, then nothing happens. I just end my attack and go back. Both player 1 and player 2 can do it. Trying to grab here. Now, when we actually succeed at grabbing our opponent, we're going to grab them, attach them to certain parts on our actor, and then put them to the other side of us based on what the animation is doing. So this is the back throw. And it looked a little janky. That's because one of the things we're going to have to fix in the next episode is the camera. So the camera only follows the 2 players and their capsule colliders. Now we can make it work with their mesh quite easily, but if you do that, it's going to throw off some of our parameters. So more than likely, what we actually want to do is keep the camera focused on what's going on with our characters, even when they're not in control of themselves. So you can see that the mutant on the left is the one doing the throw, and he's still in the throw animation on the right side, but the camera snaps. So that's one thing we'll have to fix next time. Another thing is, let's take a look at how the mutant actually looks when we're picking him up. It's not bad. He is getting picked up and rotated around, but he's not getting picked up and at certain points. So we are going to apply animations to the mutant in the next episode while he's being grappled, because as of now he's not. So you can see he kind of just picks him up and tosses him backward. Again, not bad. It is rotating as it should and things like that, but we want to make sure that he's facing the right direction and that it looks like he's actually being held there, not just kind of stiff as a board, grabbed and placed where we want. So those 2 things will need to be adjusted in the next episode, and of course I'll be covering forward throws as well. So yeah, but this is still a good start to grapples, and we're going to use a ton of this in the next episode, so it's very important if you want to complete grapples that we get this logic in first, and then we'll get over to the other logic. So to get started, let's add a variable in our code class. There's only 2 sections of code we're going to be doing today. The first section is going to be dealing with updating this enum, our hitbox enum that we have. And I guess before we do this, I should say, if you're not familiar with the series, we are really far along. At this point, I really don't even know what episode we're at. I think we're at like 46. So we're quite far along in the series. If you want to catch up, I can leave a link in this icon in the top right corner to the very first episode in the series. And otherwise, if you're just interested in the throws and grapples, that's fine. But you probably should watch this hitbox episode before that, at the least. Because that will show you how I make this hitbox actor class, how I trigger collisions with the hitbox, and how we determine what to do with the hitboxes. Now we're going to add this HB hitbox underscore throw enum value to our hitbox enum. You don't have to do this. You could really just make it a strike that doesn't do any damage initially. We're going to do the damage as, you know, they hit the ground, or if we grapple them and punch them a few times, whatever. You can do damage right away if you'd like. But, yeah. So you could do a strike if you want and just apply the damage at different times. I'm going to make a new hitbox and make it a throw and make it blue, just so we can kind of differentiate them a bit. And then in our base template character, so for me, fighter template character, I don't have anything new in the character class except for one single boolean, which is called has landed throw. Right here, of course, make sure it's blueprint read right so we can see it in blueprints. And it's basically the same as has landed hit. Again, you could use this if you wanted, but I'm trying to differentiate them so that we can have more paths we can go on, more logic we can perform without kind of stepping on our own feet. So this will just determine if we've actually landed that throw grab where the hitbox spawns, and if we don't land it, then we just cancel back and go to the idle animation. Of course, in your constructor, set it to be false by default. Okay, and that should be all good for the code today. Let's go into our AnimBP for our character. So our character, in their AnimBP, there's going to be a lot of logic going on today. So specifically, we're going to perform logic to create a new type of hitbox called a throw hitbox. And then we're going to do all the logic to determine how to attach the enemy to our actor and actually move them as we are picking them up and doing all that stuff with them. So before we get into all that crazy stuff, let's start with the basics that we're going to need to use. So if you go into your state machine for your character you're trying to implement the throw on, then you can see I've added two new states. I've added a start backward throw and backward throw connect. So basically, idle will go to start backward throw. If backward throw spawns the hitbox and the hitbox collides with the enemy, we can then go to backward throw connect. Otherwise, we'll just return to idle. The throw attempt did not succeed. So there's no reason to continue doing the throw animation. We wouldn't be throwing anything. It wouldn't really make a lot of sense. So idle to start backward throw is going to, for me, just be was heavy attack used, since I'm just using that in place of pressing two buttons to perform a throw at the moment. But you can use whatever logic you want to go from idle to start backward throw. I went ahead and I added new transition event. So instead of, normally when I do attacks, right, so like if I did idle to medium attack, I would do start attack transition. Again, separating the logic, I'm going to do start throw transition and end throw transition. So we will cover what those do in a second, but the only logic is if was heavy attack was used to go from idle to start backward throw. So if it was, then we can go into this animation. So basically if I press Z, because that's what my heavy throw is, then I can go into my backward throw. So let's go into that state, and it's got this, mutant throw backward, which this is the, again, this is the attempted throw, the attempted grapple. Doesn't mean it's going to connect. This is what I'm going to do when I press the button, and then we'll perform a check to determine if we're supposed to continue with the throw. So I have 3 anim notifies in the animation itself, in the mutant throw backward. That's what mutant throw B is. And I've made it a little bit more specific than is necessary, but I just wanted to show exactly what I was doing. So I have start throw grab, try, active throw grab, and end throw grab, try. So the try just means, again, because this is, we're attempting to grab. We haven't connected yet. And I don't actually do anything with this logic to start throw grab try or end throw grab try. I have them in my event graph. If I go back to my AnimBP event graph, and they're just empty right now, there are definitely things you could do with them, like causing damage at these certain times, or switching to other animations other than idle if you need recovery or something like that. I'm not doing anything with it, but I just want to show you that you could. So here's start throw grab try and end throw grab try. I'm going to be using the active throw grab, so you'll be seeing that in a few minutes. But so that's this animation. And then if we go back to our state machine, of course it's not set to loop because I don't need it to. And then I don't have any transition rule on start backward throw back to idle. It's basically just if the animation completes and doesn't have another transition to go to, it will return to idle. So I have the end throw transition event, as I mentioned earlier, on it, and I made sure it's automatic rule based. So since it didn't have anything to go to because we didn't connect with our hitbox, then we're going to return to idle. Otherwise, let's do the logic if we do connect. Start backward throw can also go to another state here. It can go to a state I made backward throw connect. As I said, add state, and then you can call it whatever you want. I just like the word connect because this means that I know that I've actually landed my throw attempt. And we can only get here from start backward throw. We don't want to be able to get here from idle or anything like that. And it's going to have the logic has landed throw, which was the variable we made earlier. Now we haven't set this variable yet, so you won't be able to actually reach this state, but that's what should be in here. You just grab your character reference, grab has landed throw, and set that to be the transition rule. Then I do have a custom event called grab successful. So this will determine what happens when we connect our grab, what logic we want to perform. Then we enter the state. So I have mutant back throw connect, and then I do this logic, which he's actually turning around and throwing him the other direction. I've just cut it in a way that it kind of looks like he's just slamming down at the ground, but he's facing the other direction that he was. And we're flipping the character around the other way, the enemy that we grapple around the other way. So I also have start throw grab here, which I don't do anything with, but again, you could. I do have end throw grab being used here because this is when we're going to release the player from our grasp. We no longer want to be grappling them. They can go into their recovery state or their, whatever sort of damage state you want, but we want to release control of the enemy at this time. So we are going to be using this. So make sure you have at least the end throw grab somewhere in your connect animation. Just so you know, all these animations are just from Mixamo. So I have a video on how to import them if you need help with that. They're free animations online that you can use until you get your own animations. Or just use them forever, like I will. Okay. Again, I don't set it to loop, and then we return. And the last thing we need to do is return back to idle once that is done. So again, I make it automatic rule-based, so as long as it doesn't have anywhere else to go, and it doesn't have anywhere else it can go, since this can only return to idle, then it's going to do that once the animation is done. And then I also have the end throw transition event here as well. So both the connect and the attempt have the end throw transition. Okay. And we're good with our state machine. So let's go back to our event graph and let's cover the events that we just went over. So basically, let's go over what logic the events are going to have that we were tying to the states in our state machine. First of all, start throw transition, end throw transition. So start throw transition should make it so we can't move, simply because we don't want to be able to move when we're starting our throw. Once we've started our throw, that's the position we're going to do the check from to see if we connect. So start throw transition, so check if we can move or not, and then disable it. And then we are going to do the basic logic we always do, reset variables. So we set all of our booleans back to default and all that good stuff, and then we clear our hitboxes because we don't need any prior hitboxes that belong to us in memory at this time. And then end throw transition is going to go through the same loop that end attack transition does, where basically just resets variables and clears hitboxes. Again, this is a bit overkill, but I just keep doing it. It's a safe way to make sure that we are not overwriting variables that we need to keep, and we're not keeping a bunch of stuff in memory by losing access to hitboxes. So I just like to do it every time we add something new that adds a little extra step in our flow. We make sure that these stay the same. Now you'll see my reset variables has a new boolean here called reset button presses. I'm going to cover how to fix some of the issues we've had with our X light attack, or our X attacks in this series. So these are like our shadow moves or our meter burn moves, those things. I do have an episode on that, and the logic is there to make them work, but the timing is really hard to get down because we don't have logic to press two buttons at the same time, as I was just talking about. So you kind of have to press them really, really fast and get them in the right state, and it's just not convenient. So at the end of this episode, we'll be covering how to make that a lot easier and work a lot better. Also, at the end of the reset variables function, you can see these are some changes I've made for the X attack, so we'll skip that now. But you can see at the end of the function, I am setting has landed throw back to false. Okay, So this is just my character reference, and I'm setting it back to false when variables get reset. Okay. Good. Now, we should go and see what logic we can do for the actual throw itself. So the logic we're going to be performing for the throw comes in 3 different places. It comes from 3 different anim notifies. So it comes from the active throw grab anim notify, the grab successful anim notify, and the end throw grab anim notify. So active throw is the mutant throw backward attempt. This is the attempt. This is when I would want to check if we've connected or not. So this whole first part is just wind up. This is where I spawn the hitbox. This is to say, okay, we're at a point where I feel like this part of the animation should be where I grab a hold of the enemy if I collide, and then start performing the logic. So we're going to spawn the throw hitbox here at the active throw grab anim notify. Then we have the end throw grab that I mentioned earlier, which is when we release the player, or release the enemy, when we are done with our grapple, or our throw, whatever you want to call it. Okay. And lastly, it was grab successful, which grab successful comes from our state machine. When we go from the attempt to the connect, I have it as a start transition event. These are the 3 anim notifies we're going to need to do to perform all of our logic today. So first of all, we're going to create a new function called create throw hitbox, which if you're familiar with the series, you know we've got a bunch of them. I have like create active hitbox that looks like this. Well, guess what? You're going to be doing something very similar. So if you open the create throw hitbox, make a new function, hit plus, call it create throw hitbox or whatever you want. And then here's the logic. I'll cover it just in case you're not familiar with the other functions, but if you are familiar with them, I'd recommend just copying it and replacing what you don't need. So specifically in this function, we only need the type of the hitbox, the damage the throw is going to do, which again, we can kind of force the damage to be, it can do different amounts at different times if you have multiple hits within your throw, kind of like how we did the super move. So it's not a huge deal to actually pass over the damage if you don't want the throw itself to do any damage, but just the animation within. And we're going to have the offset, of course, to where it spawns. So basically, make your function, and then make 3 variables, new parameter. You're going to make one the type, one the damage, one the offset. Damage and offset are floats, and type is our hitbox enum, which is what I was showing you earlier when we added the throw hitbox. There you go. Remember that unfortunately we changed an enum, so when you change this and you build and compile on Unreal, it'll probably complain at you, and then you'll have to close your editor and then refresh all your nodes that have hitboxes, that have this hitbox enum in use, and you'll have to recreate them. They'll still be there, but you'll just have to put in the correct values again. Okay. But once you've made your variables, we're going to do what we always do here. So we're going to spawn actor from class, and then select our hitbox actor. And hitbox actor BP specifically, so we get the collider on our hitbox and all that. Because we have a hitbox display that's invisible by default, and it has material on it. That way we can render it and check the collision. But you're going to spawn that. You're going to use the player transform from the anim BP to where we're going to spawn the hitbox. You're going to try get pawn owner, which is going to essentially get the owner of the animation blueprint if valid, and that's going to be our mutant character. We don't have to do anything with that, but we're going to set that as the owner. Drag off and hit set owner. Make sure that is the new owner, not the target. And the target is the hitbox actor. So it should look like that. Then all we're doing is setting all of our variables. So hitbox type, you can see I just reroute node from the type. Same with the damage, it just goes to the damage. Then we're performing the offset logic, which you can see we do a check. We grab is flipped to determine what side we're on. If it's true that they're flipped, it's going to perform this logic. Otherwise, it's going to perform this logic. Basically, it's determining if we should use the offset to the left or right of the character based on what direction they're facing. So specifically, you can do get transform. And you can either split it like this, or you can actually call break on it like this. And then you can grab the location and do break vector again. And then use this value to determine where the offset's going to be. Specifically, I use the offset on just the y-axis, but it is possible you can use it with the z and the x. You can also do scaling in here. We'll be covering scaling hitboxes later because I've been getting more requests for that. And then we set our hitbox location. So I'm going over this kind of quick because I've already gone over this logic in the other hitbox episodes. So if you need to, you can look at them to see how I set up the active hitbox, but it's the exact same logic. And then we're going to call the spawn hitbox function that's on our hitbox actor. This is where we set the materials and then check for collision. And then we're going to add the throw hitbox to our list of active hitboxes. I consider an active hitbox that, not necessarily a proximity or anything like that, just because it is going to end up dealing damage and because it is something that we need to actively check for if the enemy is colliding with. So I think it's valid to put it in the active hitboxes, which we should have a variable for. So you can drag it on the screen, get, and then add. And then you can add the, all these blue lines here are coming from the hitbox actor BP. So you could just drag this right in. And there you go. All right, now that your hitbox actor is spawned and we can create a throw hitbox, we're going to want to call this function and then set up the damage and all the variables that we want. So just find your active throw grab and notify right here. And then call your function, create throw hitbox, and make sure it's a throw hitbox type. Its damage is 0.15, which is 15% of their health, and then offset of -80. Okay. And then remember we were calling the spawn hitbox function in here? Well, when we're doing that, it's going to call the spawn hitbox function on the hitbox actor, BP, which is pretty simple. And we already have a switch in here on this enum that has proximity strike and throw. We're just going to add proximity strike and hurtbox. We're just going to add the throw. So I've made a new throw hitbox material, which you can see is just a blue color. So I made it translucent. Its base color is just a blue. You can see the values here, and I give it a little bit of opacity of 0.9. There you go. And then there's no other logic in here that you need to change. If you've already have this function for setting up the hitboxes, then you won't have to change anything with this. But we do need to go into our check collision function. We're going to add some stuff. So all this stuff we do, we check if we're player 1 or 2 to determine who should be dealing damage, who should be checking for overlap. Again, already do this in the hitboxes. But at the end, we have something where we switch on hitbox enum again. You can see we do it for both player 1 and 2. In fact, I never did the throw for player 2, which is kind of funny. I just forgot to do that here. But basically, if it's a throw hitbox, so once we check collision, it determines the player. And then if it collides right here, then we do this logic. So if it's a throw hitbox and we've just collided, we're going to grab our base game mode reference because we already had one in our hitbox actor. So I feel like it's just better to use this than go get an actual reference to the specific character. Grab player 1, check if they're valid. So the way you do this is you grab your base game mode reference, grab player 1, and then right click and hit convert to validated get. You can drag the line right through, make sure it's valid, and only if it's valid do you go and set has landed throw to true. So we're going to do it with player 2 since I forgot, and we'll show you. So let's grab our base game mode reference. If I could grab it. I'll bring it all the way down here. We're going to check player 2 and set has landed throw to true on a successful throw. We want to make sure we right click and convert this to validated get, and then pass throw in and make sure it's valid. There we go, just like that. And now has landed throw will be accurate for both player 1 and player 2. Okay, now the logic in our hitbox actor BP is done. So all we need is the logic to determine what happens after we spawn the hitbox and after it has collided. Remember, when it collided in the hitbox actor BP, we're setting it to be has landed throw to true. In our state machine, has landed throw, if that was true when we were doing our attempt, then we could go to our connect. So let's go into the connect. And remember, we have the start throw grab and the end throw grab. But more importantly, we have grab successful being done when we go from the attempt to the connect. So we need to go to our grab successful and notify. So grab successful and end throw grab are the last two sections we have to cover this part of Grapples. And I made functions for both of them. So you might want to go ahead and add 2 new functions. Begin throw and end throw. Just hit plus twice. Here's the 2 functions. They're nothing too crazy, but we've never done it before. Or we've never done this sort of thing before in this series, so it might be a little new. In begin throw, what I'm going to do is grab our character reference, grab the other player, and attach the mesh to our component. And then we're going to move the capsule separately. This will allow us full range over the mesh. We can pick it up and attach it to whatever bones we want and control it, which is what we're going to need to do. We're going to need this more in the next episode as well to make it more precise. But we're going to essentially be able to control whatever we want of the other player that we are grabbing by the socket name that we pass in to this function. And then in end throw, we're going to determine where the actor should be after the throw. So we're going to detach them and then place them at a position that looks good. And I made it a variable on the end throw function, a parameter. That way you can switch this for every throw you have, and it will still work. It is going to take into account if we're on left or right. And then we're going to attach the mesh back to the capsule collider. That way they still have collision, they're still in the right spot, all that good stuff. So let's go back to begin throw and let's start going over the logic. So, we're going to attach our enemy's mesh, the enemy of the player who is calling the begin throw function, to our mesh at a socket we want. A socket basically just determines what bone that we want to attach something to on our character. So it's simple enough. The way we can check is if you actually click on, in your animation blueprint, you have these things up at the top. You can look at your skeleton. I went ahead and made a new socket called left hand socket, but you can do this anywhere you want. Basically go through and look at your bones. And you can click on any of them, it'll show you where it's at. I clicked on left hand, and then you can right click and hit add socket. And I'll put a socket under this hierarchy, so it's under left hand. And now we can attach things to the socket. Again, we're going to attach the mesh, the enemy's mesh, to the socket. So what I do is I go back to my event graph, and the socket name that I put is the socket that I want this throw to connect from. I want this throw to connect from the left-hand socket that we just created. You can right-click and rename socket, by the way, to call it whatever you want. So I pass that into my throw. And then you can see I have my mutant character reference, other player. So if mutant character reference, if this is player 1 calling begin throw, other player is player 2. If this is player 2 calling begin throw, other player is player 1. So this will work for both cases. We're going to grab player 1's mesh and player 2's mesh. Regardless of who's who, we need to grab both because we're going to attach one to the other. So grab your mutant character reference. Grab your other player. Grab the mesh. There you go. And then drag off your mutant character reference and get mesh as well. That's how you get all this stuff that I have down here. And then we're going to do something called attach to component. So attached to component is a node that will quite literally, and I'll let you read the comment here. It gets cut off a little bit, but that last word is registered. Basically, it allows one component to attach to another component. Essentially, it can be just attached at the root element, or it can be attached to a socket. In this case, we're going to try to attach the one actor to our other actor through our hand socket, and we can actually determine where they get attached to as well. Like, it doesn't just have to be attached to their root element from our hand socket. So we're going to do more logic with that in the next episode. But for now, all you have to know, this order is important. So remember, the mutant character reference is the one that is initiating the throw here. The other player is the player that is being grappled and or thrown. So the one initiating the throw needs to be the parent, and the one being thrown needs to be the target. So you can right click and type attach to component, and I'm going to uncheck context sensitive. It gets very confusing when you try and do this. I usually screw it up at least once or twice. You want the target as scene component. If you hover over it, you'll see that it'll show you the target at the bottom line there. Target is actor, target is scene component. You can do either. I usually do attach to component, but you can do attach to actor as well. It will change a few things down the line, but it'll be otherwise pretty much the same. But regardless, what you need to do is drag in the mesh of the person using the grapple into the parent. That's the one we want to attach the other object to. The target that's getting attached is the player who is getting thrown. It's their mesh that we're dragging. So they're the target. The player throwing is the parent, and then we put in the socket name. The socket name I used as a variable, so you can just drag that in. You can keep everything relative and weld if you want. That stuff doesn't really matter here. Should look pretty accurate as far as that goes for now. We can get into more things you can do with that in the next episode. But there you should be able to actually attach your actor to another, and you can play with it now, and you should be able to see that that is happening. Just make sure that you actually call the begin throw function. I know we talked about making it, but make sure you call it and pass in the socket name when the grab successful and notify fires. So that's how you attach it. It's quite easy because when you're attached, it'll follow the rotation, the scale, and the location. That's what these rules are actually. So that part's good, but we want to make sure we can also release it. So if we go back into our event graph, our end throw grab, I'll show you one more time, is the end of the connection throw. So once we're ready to release the opponent and they're done being grappled, they can resume their lives normally. Then once we hit this and notify, we want to call one more function. We want to call the end throw function. So if you didn't already make it, again, just make a new function. By the way, for begin throw, if you want to make the input, as usual with all functions you go over, you click on the function, go over to inputs, hit new parameter, but we can specifically use a name here. You can use a string too, and it'll automatically convert for you, but there's no real need since we're just putting it into a name parameter. So you might as well just use a name as your type, your variable type here. Okay, so in end throw, we're also going to have an input called end actor location offset, and it's a float. Basically, this variable will determine where our thrown character is going to end up, right? Because we throw them. I'll show you right here. I have it set up to default to 2 mutants, so I don't have to go through character select every time. So as I throw the mutant, I want him to appear on the other side of me. Now I know the camera's a bit broken, but you can see that the character on the right is player 2. Now the character on the left is player 2. Now I can throw him back and forth. So there you go. That's what we're trying to do. We're trying to make sure he gets placed on the correct spot when we're done. So make that parameter, that input. And then we're going to detach the enemy's mesh from us. The way you do that is we can access it the same way we were attaching it. Just grab your mutant character reference, grab other player, grab the mesh, and call detach from component. So when you drag off the mesh and call detach from, you won't be able to see it. So what you're going to have to do is uncheck context sensitive and then search for detach from component. It's weird. These whole attach detach things usually are weird in Unreal. I don't know why. Could be something I'm doing wrong, so feel free to enlighten me. But it's always kind of a pain. But anyway, there you can find it and then just drag your mesh into the target. You can keep everything the same. I'll keep relative and all that good stuff. And then what we're doing here is we're going to check if they're flipped or not. So we're going to determine if they should be on the left side or the right side based on our offset and based on if they're flipped. So if they are flipped, then we want to set them to this location. Otherwise, we want to set them to this location. And obviously, we'll go over the location. But essentially what it is I grab our capsule component of both the player throwing and the player being thrown. So you can see I drag off and just hit get capsule, capsule component right here. And then I drag off of other player and hit get capsule component. Easy. And for the player that is throwing, we're going to get the world location and get the Y value. Now the Y value is my horizontal value. You can see it here actually. So Y is left and right. That's the value we want. We don't want to actually modify the Z or X values because if you attach an actor or a component to another component and the rotation starts getting weird, you can actually throw them off the map and things like that. If you were doing this in a 3D fighting game where you were actually like Tekken, where you can actually throw them, you know, somewhat directionally, not just left and right, then you could use more than this. But otherwise, you don't want to do this. You don't want them to be offset from the Y axis. Otherwise, your players won't be able to hit each other and want to be closer to the camera. It'll be kind of weird. So we're just going to use the Y axis. And basically, this logic we're doing here is just taking the value that it is and using the offset to figure out where it should be. So, if it is flipped, then we subtract. If it's not flipped, then we add. So we either subtract this value, the offset from this value, or add the offset to this value, and it gets put into different world locations. Now, that's the Y value, and the reason I'm doing this way, sure, you could just take the other player's capsule component and give them an offset, and it would work fine. But specifically, if we take the player that is throwing and use their offset to determine where they should be thrown, we know for a fact that the enemy will not be inside of our player. He won't be, you know, they won't teleport in such a way where, oh, I grabbed this player farther away than this other time I grappled, so now he teleported in front of me when he was done. We don't want that kind of logic. By using the offset, providing an offset from the character that is throwing here, from their capsule component, we know for a fact that the player getting thrown will pop up in the correct spot. Because we lock the players that is throwing, we lock their movement when they initiate the throw. However, we do need data from the other player as well. I mean, you could use it from this capsule component, but I like to use it from the other player because for me it's more clear to read. What we're going to do is we're going to get world location again. Just drag off of capsule component, get world location. You can recheck context sensitive. So just type get world location. Sorry for the cut there. Context sensitive wasn't working. I had to close the editor. It does that sometimes. But when you drag off your capsule collision, or your capsule component here, which is capsule collision object, you can get world location, which is what I've done here for both of these nodes. But then I've right-clicked on the return value and split the struct pin. That's how you get it looking like I have it here. And I'm just going to pass the X and Z values to the X and Z of each of these. So you can see this is Z, it goes to the set world location on both, and this is X, and it goes to the set world location on both. So basically what I'm doing is just making sure the X and the Z stay the same. I don't want to change those values at all. I want them to stay exactly as they are. I just want to make sure that the Y value changes to the new Y location that we want. So you can see this is if they are flipped, and this is if they are not flipped. You might have to change this based on your levels, how they are set up, how they are oriented. because you might be getting the opposite effect. Like if they are flipped, you might be putting them on the opposite direction of what you want, and vice versa. So make sure that you check this and set the correct location. Okay, and then we're going to do one last thing here, and we're going to attach to component, and we're going to reattach the mesh to the capsule collider. So you can see I actually bring the mesh down here, and it goes underneath everything. So this blue line that's going into the target of this attached to component is the mesh. The one that's going into the parent is the capsule collider. We don't need a socket. In fact, I don't believe the capsule collider has any sockets. Could be wrong, but we definitely don't need a socket. We just need to reattach it. So as you do, type attach to component. You can uncheck, and then it actually goes right out of the range of where it's at. But if I right click a little higher and do attach to component, you'll be able to see it. There we go. You want the one that's scene component again. Remember, this is the mesh right here. We drag this into the target. We're reattaching the mesh to the parent, which is the capsule collider. You can keep everything relative again. Don't need a socket name. Just drag your code flow through and you're good to go. Now, this will work. This should let you begin your throw, end your throw, all that good stuff. They will become unattached, but you will notice an issue. Make sure you call end throw on end throw grab, by the way, and give your offset. You will notice an issue where your character might not be flipping the correct way due to this, because we've actually, by detaching the mesh from the capsule collider, we've actually changed the parent and child order within the hierarchy. So what I mean by that, I'll give you an example. If I were to do this and spawn into my scene, and I look at my world outliner, and I grab my mutant character BP, I'll bring this back up so you can see it. The mutant character BP, as you change things, you can see these values move. So this one I'm looking at happens to be player 2 right now. Okay? Now, as I change that, then these values also change on the screen, right? You can see that the location Y of this character is changing. Well, if you remember how we were doing our flipping characters so that enemies, well, players always face their enemy, I was actually grabbing the mesh component that is a character of our capsule component. So when we detach this, it actually gets put as a different part of the child, a different part of this hierarchy, and thus our logic no longer works. So if you've been following the series for the logic that flips our characters around, we're actually going to need to make an adjustment there. So go into your fighter template character.cpp and go down to the tick function. Now I'm going to change quite a bit here, but there's a lot that we can remove as well. So I had this function set up, and it was going through checking our character movement versus the enemy's character movement, which honestly just doesn't really make a lot of sense. We don't need to do that. We can just check the Y locations to determine if they're flipped or not. We don't have to grab their character movement component. In fact, we don't even use their character movement component, so it doesn't make a whole lot of sense. So what we're going to do now, if you have stuff in here, feel free to take some time, look this over, and use this instead. But the big changes I made are I'm not getting character movement components anymore. So I just check if other player get actor location.y is less than or equal to get actor location.y. And then check if it's already flipped, and then else if it's not flipped. And then everything in here is going to be new. This stuff is going to be the same, but where we set the mesh is going to be new. And this will work for all instances. It's a safer system in general because we can check if we ever detach the mesh again for this child component. If you wanted to be really safe, you could loop through on tick and actually check for the mesh, but of course that'll give you a performance cut doing that. So I think this is okay for now. If we find into a case where we need that, I will obviously update it and let you guys know. But for now, what we're doing is, as opposed to just grabbing the capsule component like we were doing and then getting child component 0, which was working before and would work as long as the mesh never detached itself, we're now going to get the child component. We're going to get capsule component, get child component 1, and get the name, and see if it contains character mesh, because that's how this shows up as a child component. It's called character mesh 0. If you're debugging, you can see this. So that's how I know what the name is. Then if it does, then we want to set our mesh equal to that component. Otherwise, if it doesn't, then we want to go to the last element in the hierarchy of children here, get the name, and see if that contains character mesh. If it does, we want to set the mesh equal to that value. And then if mesh is valid, because we create it here, then we want to do all the logic we were already doing. So before, we were making a mesh and doing this, but we weren't doing it in a way that allows us to move things around. It had to be at that specific index. Well, when something gets added, unless you choose where to add it back in the hierarchy, it's going to get added at the end. So this will work. Okay, so to do this, type it out. It's pretty simple in terms of actually making it happen, but of course what I'm doing is a bit complicated. So get capsule component we were already doing. This is getting the capsule component of our character. We were just doing that in Blueprint. But we're doing something called get child component, which the child component is, well, I got rid of it now, but if I were to continue and move this off to the side, this is the capsule component, so we're getting the children of this, but we're looking for the mesh. But it also has the cine camera, so you have to be careful and make sure we're getting the right one. So we're getting our capsule component, and we were getting the mesh. Great. And then we were getting its name. Quite literally, you can just type all this stuff out. Dot contains and character mesh. Character mesh. So dot contains will check the string. So in this case, it'll check the name of this child component. And if this exact string is anywhere within that component it's checking, in this case get name, then this will return true. So that's why we can put it in an if statement. So essentially, if the first child of the capsule component has the name character mesh of any sort, then it's true, and we can set the mesh equal to this component. You can see this line is the exact same as this part right here. We're setting it equal to that. Else, we get our capsule component, get child component. Then this next part's the index. This part right here is the index. We get our capsule component again, okay? And then we call get num children components -1. And that's our index. So get num children components does what it sounds like. It's going to return how many children this capsule component has. Now remember, that returns the actual value. So as you return that, it's going to return, like if there's 2 elements, it's going to return 2. As far as indices go, like since this is an array of child components, then it's going to be index 0 and index 1. Those are going to be your 2 child components. So you have to make sure you subtract 1, that way we don't go out of bounds. So the first index is 0, the second index is 1. That's why we do -1 here. But then we still get the name, and we still do dot contains and check for character mesh. And then if that's valid, then we set the mesh equal to that. So you can see get capsule component, get child component, and then I do the same logic. This is the same as this. So don't get confused. I know that looks like a lot of stuff going on, but it's not too bad. And then just make sure you do if mesh before doing this, because if it's not valid for whatever reason, if we can't find the mesh as a child, then you don't want to try and perform operations on the mesh. You will get a crash. Then you copy and paste and do the exact same thing in the other side. Okay? There's ways to optimize this as well, so feel free to do that. But there you go. So now your character should be able to be grappled. Your other character should be able to grapple them. You should be able to place them down after they're attached, and they should be on the opposite side of you. And they should be able to flip correctly. Okay, so that concludes the grapple section for part 1. There's a lot going on here, as you saw and can expect. We're going to be doing another episode on this where we cover adding animations while they're getting grappled, making the grapple itself look a little bit better for the character being grappled. That way they're not flipping through the air kind of just randomly, or what appears to be randomly. It's not randomly. But before we end this episode, we are going to fix an issue with the X attacks, the meter burn attacks, like I mentioned. So really quickly, if you're interested in fixing that issue, and checking that out, I'll show you what I've done. So now what I've done is in my reset variables, I have logic to reset button presses, and it's set to be true. But reset button presses essentially means, do we want to reset all the buttons we've pressed, or do we want to hold on to them for a bit? And the reason I am now doing this, so if you click on your reset variables function, I just added a boolean. The reason I am now doing this is because when our logic dictated in our state machine for our light attack is that we can go from idle to light attack if we have the boolean was light X attack used. But the way this is set in code, Control F for that shortcut, by the way, is to check if was light attack used, and then can use X attack, which just basically means we're at a point in the animation where we can use it. So, okay, sure. I mean, that makes sense. We want to be able to use the X attack if we're using the light attack and we have the correct amount of super meter, but we don't have functionality to press 2 buttons at once. So we're just going to go into the light attack animation, and then it's going to get reset back to false, and we're not going to be able to go to this. And you're absolutely right. That's why the timing was so hard. So what we need to do, I will open up my X attack animation, my X rifle punch. You can see I have my animation here. It's good to go. I didn't change anything with them, just showing you. And then I have my rifle punch animation here, and I have my can use X light, which I've already had. It was done in the X attack episode. And when this is triggered, what we want to do is we want to set variables to be able to transfer from the light attack to the X light attack. And again, we're already doing that. We can go from light attack to X light attack. All we need is was light X attack used. Okay, so good. We're not calling start attack or end attack or anything that will reset variables here. And when we call idle to light attack, or any attack where you can go from one attack to your meter burn move or to an X attack move, we want to now call a different event as opposed to start attack transition. Because what we're now going to do is we're going to actually check and see if we've done the correct inputs to go from our regular attack to our X attack. So this doesn't have to be light attack. You can do it for medium as well. I just haven't set it up yet. So instead of start attack transition or doing some weird stuff with it, what I do is I call an event called start potential X attack transition. Now, if we go into our NMBP, I have start potential X attack transition. I do not reset my button presses when I call this function, and then I still clear my hitboxes. So in reset variables, we're using this boolean into a branch, just like that, and resetting every one of our regular button presses, light, heavy, medium, super, and then my X attacks, if that boolean is true. If it's false, then I'm just setting can use X attack to be true, because can use X attack, again, is just the identifier to say, yes, I can transfer from my light attack to my X light attack. And then I'm still setting has landed throw to be false, but that's actually okay. So, okay, now if you see how this works, anytime we're doing regular attacks, we do reset the button presses. So these just get reset back to false. So we don't lose any functionality by doing that. But if we want to do a potential X attack, if we have the ability for the player to input a move and then go to their meter burn version of that attack, then we don't want to reset those buttons. And the way this ends up coming out is if we play, and I'll give you a full run through. Yeah, we'll both be muted just to make things simple. I'll do it on this stage. And now I can go ahead and give myself full super. Little cheat I added. If you want to see that video, I'll leave an iCard here. But what we can do is I can use my light attack all day. It won't screw up any logic. I can still use it. I can still use other attacks, right? Because they're still getting reset when I'm just using the one value. Because they actually get reset when I return to idle as a safeguard. Remember, we reset our variables. I mentioned it earlier. I know it's a little bit overkill, but it will make your system nice and secure. Now, if I want to use my X light attack. Remember, now when I use light attack, then I'm using my potential, my start potential X attack transition now. So my light attack does not get reset until I end the animation. So if I go from this to light attack, you can see that I actually use my X light attack. That's the symbol in the input stack on the top left, that little dotted line one, and the X light attack is represented by slower animation speed, and also it'll do more damage. Okay? So in doing this, understand that it does create 2 hitboxes, because I've never cleaned up the X attack hitboxes, and we're going to be doing more with these in the future, and we're going to just get more into the meter gameplay in the future as well. But I wanted to add this to this episode. I know this episode's long, but I think it's important that you guys know about that. I didn't forget about the X attacks. I just had to figure out the way I wanted to do it, and I think that's the best way to do it. So anyway, guys, that's how you can use X attacks now. So you can go ahead and implement them for all your light, medium, heavy, special, however many you have, throws even. It'll work for all of them, and now it's easier to perform. Thank you guys so much for watching this video. I know this was an insanely long one, so I appreciate you sticking with me, and I really hope that I helped you learn grapples and throws and fixed up that X attack issue that we were having. If this video helped you or taught you anything about grapples and throws, please subscribe. It does more for the channel than anything else you can do, so I really appreciate it. And if you do, you'll be able to see all the updates that I make on this game and all my other series. We've got a first person, third person, and Super Smash Bros. Style game right now. So if you'd like to join the community, you can actually choose to become a member on YouTube memberships or support us on a tier on Patreon. They'll get you the same benefits, so if you decide to do it, it's all up to you which one you choose to do. It just supports me as a creator, lets me make more videos because I can spend more time on it, and it just gets you some perks, like you can actually get access to these templates when they're finished, and they go on the Epic Store for free, so that's always good. If you guys need any help with this tutorial or any of my tutorials, please feel free to join the Discord. You can find the link in the description. Just click it, you'll join the community, and then we'll be happy to help you with any of the issues you had. Lastly, guys, if you want to come support us on Twitch, we're still struggling through Demon Souls and Resident Evil 7 DLC. You can come help us beat these games once and for all at twitch.tv/Shawnthebro27. Thank you so much, guys. Thank you for everything. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.